All right, ladies and gentlemen, in this video, we are continuing what we know about volumes and solids. And in this case, we are going to start looking at how to find the volume of pyramids. And so the goal of this whole lesson is you're able to derive, yes, derive the formula for volume of pyramids and use said formula to find the volume of a pyramid. So let's take a look here real quick. The pyramid and the prism have the same height in this case. So what ends up happening here? Well, when the pyramid is filled with sand and poured into the prism, it takes 3 pyramids to fill this entire prism, right? So if I took 3, right, of these, I could fill up the whole prism, right? Just of sand or water or whatever you're talking about, right? So what I want you to do is I want to challenge you. I want you to challenge you to pause the video for a sec and to think about how can you write a formula based on this concept, right? How can you take a concept to write the volume of a pyramid based on this concept here? Well, what you have to ask yourself is, well, what is the volume, first and foremost, of this prism? Remember, the volume of the prism is the area of the base times the height, right? The area of the base times the height. This is a rectangular prism or a square prism, so it's literally just length times width, or side times the height, right? Side times the height, or length times width times the height, depending on if it's a rectangle or a square specifically. So if it took 3 of those, then that means that one of these is a third of the whole prism. It's a third of the whole prism. And if the whole prism is big B for area of the base times the height, and I'll kind of just put here, where big B is equal to side squared if it's a square, or length times width if it was a rectangle, or whatever the case may have been. So specifically speaking, the volume of our pyramid is 1/3 of big B times H. And once again, you may see it written like this, where you have big B times H divided by 3. So it just kind of depends on what the concepts are that you are given. Let's take a look here at an example. The Great Pyramid of Giza is the largest of the original 7 wonders of the world. The pyramid originally had the dimensions shown below. What was the approximate volume of the pyramid? All right. Well, in this case, we end up seeing that we have another square pyramid here, a square pyramid down at the bottom. So we have 755.5 for our base. So remember, the volume is going to be 1/3 of big B times H. So the volume here is going to end up being 1/3 times 755.5 squared times the height of 485. So the volume will end up being 755.5 times itself, and then multiply that by 485. Right now, just to give you an idea of where we are, we're at 276,828,421 divided by 3 gives us 92,276,140.4 feet cubed for the volume of the Great Pyramid here. All right. So always kind of also keep in mind here that you can utilize it in different ways, but depending on the situation, maybe the volume of a pyramid is based off of a composite solid or anything else, really. So let's take a look at one more quick example. This is originally, Khafre's pyramid had a height of about 144 meters and a volume of about 2,218,800 cubic meters. Find the side length of its square base. Remember, volume equals big B times H. The volume here was 2,218,800, and that is equal to the 1/3 times big B times H. Usually didn't look right. 1/3 third times big B, but I'm going to make big B S squared here, because if it's a square, it's just square times square, or side times side, and the height is 144. So let's go ahead and solve for this. 144 divided by 3 is already 48, so I'm going to simplify that first. So 48 S squared. So then 2,218,800 divided by 48 ends up giving us that 46,225 equals S squared. And if I want to solve for S, the opposite of squaring is to square root on both sides. So that means we end up taking the square root of 46,225, and the square root would be 215. We're in meters, 215 meters.